What's up, everybody? Welcome back. Episode 4. I know I keep getting comments asking me where the rest of this series is. It's cooking. You just gotta give your boy a little bit of time. But, anyways, this episode is the first, it's really like the first episode. Even though we're at episode 4, the last 3 episodes were all build up to what is going to be the series of plants as we know it, following that phylogenetic tree. But today is like our first stop, Bryophytes. So you're looking at some of the most ancient and resilient plants on Earth. Some of them, think simple thalloid structures, very simple vasculature. They survived mass extinctions. They are on every single continent. It's the only plant that is on every single continent, including Antarctica, where they freeze over winter and then unfreeze, grow for a little bit, and then go back into freezing. These plants, like I said, they can survive freezing. They can survive desiccation from being dried out and come back to life. That's why they're nicknamed resurrection plants. Moving on, breaking down the 3 different types of bryophytes that we're going to be talking about today, we're going to start with mosses. And obviously, everybody knows what mosses are. We're pretty familiar with mosses at this point. And there's more than 12,000 species worldwide. We're finding new ones all of the time. In fact, it's one of the main problems that bryophyte scientists find trouble with, is that we're actually losing them faster than we can find them because of climate change. Anyways, they're extremely incredibly diverse, from the tiny Epherium moss that's smaller than your fingernail to the massive Dawsonia moss in Australia. Of course, it's in Australia, that grows over 2 feet tall. Mosses have these amazing little leaf-like structures called phylids, and they're called phylids because they're not actually leaves. They don't serve the same functions as leaves, so they're called phylids, not true leaves. We'll talk about that in a later video, phylids, microphylls, and megaphylls. True leaves are either microphyllic or megaphyllic. They're not phylids. Anyways, and something that's cool is that when they completely desiccate and dry out, they can stay that way for months and months and months and then be brought back and rehydrated. I actually did this for an ecological study where it's common for herbariums to take specimens and you don't have to do all the traditional drying methods that you would have to do in more vascular plants. You could just straight up dry the moss out and then put it in its container because they survive desiccation so readily. On to the second group that we're going to be talking about with bryophytes, which is a super interesting group and one of my favorites within the 3 group. I think it is my favorite within the 3 group, which is the liverworts. I think liverworts are super interesting because their structure is so unique. And before I did my ecological study for past work, I was really interested to get into their diversity and their range and their structure. And speaking about their structure, they are literally liver shaped, or at least the Vikings thought so, and that was part of their namesake. And they actually thought that would actually help with liver conditions, which was a sign of the times back then. But they don't. They do various other things. Similar to mosses, they shoot out spores. But what's interesting about liverworts is that they create these little cups on them called game cups. And it's interesting that they create those because that's a different apomorphic organ that isn't present in mosses that they do. And it's kind of like a gun almost, and they're shooting their progeny in the form of those sporophytes that we're talking about. And once those sporophytes hit the ground, they become gametophytes, and the gametophyte generation takes off, and they do it again and again and again, and that's how they reproduce. An interesting liverwort that you could probably go out find right now near some stream banks or riversides is snakewort. I think it has this really interesting structure. I'll throw it up on screen for you guys to look at. Lastly, the 3rd group that I'm going to be talking about, the hornworts. They're the weird cousins of the bryophyte family. They get their name from these horn-like structures that they make and can keep growing and growing for months. What really is wild about hornwort is that they have a unique relationship with cyanobacteria that helps fix nitrogen. And this is some of the first iterations of this relationship between cyanobacteria and nitrogen fixations between plants and cyanobacteria. Now you're thinking, okay, they're interesting, but why should I care? Well, bryophytes are what scientists call ecosystem engineers. In previous episodes leading up to this one, we talked about soil formation. Well, these guys are the ones who started breaking down the rocks, started breaking down the materials that are on land to form soil. So they are the ecological engineers that engineered the soil for more complex vascular plants to then grow on later on. They act as, in contemporary times, they act as nurseries for seedlings, and in carnivorous plant care, we use them to mulch. They're a great living mulch, organic living mulch. And remember that bryophytes absorb water directly through their surfaces because they don't have true roots. They're rooted with rhizoids, which are just root-like structures that don't actually absorb or transport anything because they don't have vascular tissue. But they can absorb up to 20 times their weight with some species. So that makes them very good living mulches and the ability to survive desiccation. That's why you see them so much in the plant trade. So not only can they do all of that, but they sequester a significant amount of carbon. In their natural environment in sphagnum peat bogs, they will actually fix about 1/3 of the world's carbon that is fixed in soil is fixed by those peat bogs. So that's a really important ecological implication of these bryophytes. So besides the soil ecological implications, there's also air implications and environment implications for bryophytes. When you're in an area and you see heavy bryophyte activity, it's indicative of a healthy environment, or at least something that's less polluted, because bryophytes are sensitive to pollution and sensitive to toxins in the air and things like that. So they are very good in indicators of healthy environments. But in conclusion, there you have it. Bryophytes aren't just simple green carpets for you to walk over. Try taking a look at them, because they really are ancient survivors, ecosystem engineers, climate regulators, indicators of environmental health, all rolled into one phylum of plants, which is the bryophytes. If you like this kind of content, leave a comment, drop a comment for any kind of tips. I'm trying to get better at this whole content creation shtick. Let me know if there's any plant topics you want me to cover or go over. I'll do that. Let me know down below. Thanks for watching.